Hello, welcome back to the channel, to the video series where we are reviewing the principles and practices of commercial construction. This video is about chapter 12 and that is dedicated to the floor systems. So when the structural frame is completed, that means that the major phase in the construction of the building is done. So as a major component of the building frame, the floor system will determine to a great extent the construction sequence for the entire building. In floor systems suspended above grade, the subfloor is considered part of the structural frame and it must be capable of supporting all superimposed design loads. Design loads such as additional floor toppings, floor finishes, and partition walls, as well as occupancy life loads, must be considered when designing the subfloor. So, um, floor systems in buildings can be divided into two parts, the base of subfloor and the application of the floor finish. Subfloors are constructed of wood, concrete, or a combination of concrete and steel. In wood frame building, the subfloor is supported by floor beams or floor joists. It may consist of wood sheathing or metal decking supporting a lightweight concrete slab. In steel frame buildings, a subfloor may be a reinforced concrete slab supported by the steel floor beams. An alternative approach to subfloor construction in a steel frame building is to use metal decking covered with a cast-in-place concrete slab. Precast concrete floor sections can be used to advantage in both steel and concrete frame buildings, allowing for fast erection times and relatively long spans between supports. The construction of the subfloor is related to the material used for the structural frame. In a reinforced concrete framing building, for example, the concrete slab must be placed monolithically with the beams and columns of the frame. In timber and structural steel building frames, the supporting beams and columns are erected prior to the start of all floor construction. So let's move to the first subsection, that is the timber subfloors. Wood subfloors are constructed in two ways. For heavy load conditions, the 2x4s or 2x6 are placed on the edge at right angles to the floor beams. The sections are laminated together side by side using spikes, usually in a controlled random arrangement. This allows for the use of sections of variable length, resulting in a minimum of waste. Rules for the location of end splices are provided in wood design codes. So here you can see laminated wood deck on timber frame. There is a picture illustrating that, as well as the plank deck on steel frame. And that is the more common approach to use heavy planking laid flat. To ensure tolerable deflections, the thickness of the plank subfloor is based on the distance between the supporting beams and the loads that must be carried. So take a look at the plank decking applied on the open web joists. Here there is a picture showing that. And we are moving to the next subsection, and that is concrete subfloors. There are two types of concrete floors, slab-on-grade and structural slabs. The slab-on-grade is a floor placed directly on a prepared subgrade to prepare a clean and durable surface for the building occupants. The structural slab, which must span between supporting walls, columns, and beams, must be able to support its own dead weight and the superimposed load that is designed to carry it. So the strength depends solely on the concrete strength and the amount of reinforcing steel that has been used. So slab on grade may be placed before any other portion of the building has been constructed on a prepared subgrade to provide a level surface on which the structural frame is erected. Take a look at the picture. You can see the power screeding on a slab on grade concrete floor. To ensure that the slab will provide a long-lasting and serviceable surface, the Portland Cement Association puts forward the following recommendations. The subgrade must be uniform and have adequate bearing capacity. 2. The concrete must be of uniform quality. 3. The slab's thickness should reflect the anticipated loads and should be consistent without abrupt changes in the thickness from poor subgrade preparation. 4. Provide proper jointing of the slab. 5. Provide good workmanship. 6. Provide a proper surface finish for the anticipated loads. 7. Use proper repair procedures if and when they are necessary. So, a standard procedure to produce a good concrete slab on grade may be as follows. So, the first one is to backfill all ditches and trenches under the floor with material similar to the surrounding subgrade, obtaining similar density and moisture content. Then isolate all columns from the floor slab by boxing them with square wood or metal forms or with round fiberboard forms. Then the next one is to isolate the walls from the slab by fastening strips of asphalt impregnated fiberboard or other joint material. Prepare any changes in slab thickness as at doorways to be as gradual as possible and at slopes if not more than 1 in 10. 5. Use a template with legs equal to the slab thickness to check the grade. 6. Provide a vapor diffusion barrier should water vapor migration through the slab be a concern. 7. Place the reinforcement, mesh or rod as specified in plans. And then 8. Set screed strips in the same elevation at convenient intervals throughout the area to be concreted. So please take a look at the picture. It's typical screeds and basers. You can see that. You can see pipe screed, T-bar screed, wood bar screed, bar joist, loose fill. Then you can see the height adjustments. You can see the soft fill, turn base, turn bolt, turn jam nut, flat and standard. That is important to understand how they're used. So the next step is to oil the screed strips. That was number 9. 10. Place the concrete as close to its final position as possible. Consolidate with an internal vibrator, especially at corners, walls, and bulkheads. 11. Straight edge the concrete to the level of the screed strips. 12. Smooth the surface with a long-handled float or derby to remove the high and low spots. Cover with damp burlap until ready for the next operation. 13. Float the surface with hand or mechanical floats as soon as the concrete supports the weight of a worker. If specified, apply metallic aggregate hardener 15, trowel to a hand-dense surface with hand or power trowels. Then 16, cure by covering with a waterproof curant paper, 2 coats of curant compound or burlap kept moist at all times, or a layer of damp sand. That's another way to keep it moist. So the next iteration is to remove the forms around columns and attach joint material to the vertical faces of the slab and the base of the columns. 18, provide control joints to a depth of at least 1/5 of the slab thickness with a power saw at spacing between 24 and 36 times the slab thickness in both directions. Number 19, seal the joints with mastic joint filler. And then number 20 is to cure it for at least 7 days before allowing regular traffic on the floor. So let's take a look at the structural concrete floor slabs. There are a number of types that are available, and the type that is used for a particular building depends on a number of factors, including the intended use of the building, the type and magnitude of the loads, then the length of the span between supports, and the type of building frame, as well as the number of stories in the building. So let's take a look at the one-way solid slabs. And those are structural slabs that have the load carrying steel running in the direction of the span, with temperature and shrinkage steel running perpendicular to the span. One-way slabs are used when, excuse me, where the span of the slab is relatively short, and they are designed as single span or multi-span. One-way slab formwork and the placement of the reinforcing steel are straightforward, allowing for the integration of the slab with structural steel framing and masonry, as well as with reinforced concrete frames. Take a look at the pictures. You can see the beam and slab floor, and you can see the diagrams showing reinforcing steel in solid one-way slabs. So two-way solid flat slabs, two-way flat slabs are have load supporting reinforcing steel running in 2 directions. Beams or walls are not necessary in the support of this type of slab, as it can be placed directly on supporting concrete columns. Thickened sections of the columns, known as drop panels, ensure that sufficient shear capacity is available in the slab. In the past, column capitals have been used with or without drop panels. But now it has been eliminated to a great extent because of higher forming costs and because column capitals used alone were not large enough to fully mitigate the shear issues. So let's take a look at the there are a few pictures here showing the column capitals and flat slab floor with drop panel as well. So, and we are looking at the two-way flat plate slab. So two-way flat plate slab is similar to two-way solid slab with the exception that it does not have a drop panel. Flat plates are very efficient from the point of forming, steel layout, and total thickness. The slab thickness varies from 5 to 10 inches, and maximum practical spans reach approximately 32 feet. Because of its simplicity and minimum structural depth, the flat plate is popular in high-rise offices and apartments. And you can see there is the flat plate floors. We're moving to the next one, that is one-way joist slab. And one-way structural system consists of a series of concrete ribs or joists that contain the reinforcing steel that cast monolithically with a relatively thin slab. The ribs, in turn, frame into supporting beams. And the main purpose of using such a system is to reduce the dead load by concentrating the reinforcing steel in the ribs and eliminating the concrete between them. The slab thickness varies between 2.5 to 4.5 inches, and the joist depth varies from 6 to 20 inches. Standard pan forms produce between rib distances of 20 and 30 inches, and maximum spans are about 45 feet. So we are moving to the next one, that is the waffle or two-way joist slab. In this type of floor system, ribs run at right angles to one another. The ribs are produced by the use of dome pans, resulting in a two-way structural systems. So the domes are available in various sizes, with two sizes that are more common. It's 19 by 19 or 30 by 30 inches. And dome height vary from 8 to 20 inches in 2-inch increments to produce rib depth appropriate for the anticipated spans of the floor system. The slab depth can vary from 3 to 5 inches, and the rib depth can vary from 7 to 20 inches. The normal rib widths are 5 and 6 inches, and the distance between rib centers can vary from 24 to 36 inches. So the span range is from 25 to 50 feet. You can see the pictures and the diagrams of that. Let's take a look at the post-tension concrete slabs. Adding post-tensioning strands to concrete slabs produces sections that can span over greater distances than non-pre-stressed sections, and yet are able to support greater loads with less deflection and virtually no cracking. High-strength steel strands or tendons enclosed in protective plastic sheathing and distributed throughout the slab at predetermined intervals. So the sheathing ensures that the concrete does not bond to the post-tensioning tendon. Once the concrete has cured sufficiently, the tendons are tensioned to a predetermined stress and anchored. The tendons are raised higher above in the form in the vicinity of the supporting column than at the midspan of the slab. This arrangement ensures that the compressive forces induced in the concrete slab by the tendons counteract the tension stresses produced in the slab by the anticipated loads. So you can see there is a picture of post-tension cable with slab anchor, wedge anchor, and sheathing. And you can see the field application of post-tension cables being positioned on chairs here. Then you can see the two-way slab ready for concrete. That's another picture, as well as the post-tension solid slab with post-tension ribbon beam. So let's move to the next subsection, and that is floor slab form and work. So forms for a beam and slab floor consist of slab forms and the shores that support them, beam forms and the T-shores that support them, kickers between slab and beam forms, and supports for the edges of the slab form over the T-shores. take a look at the picture showing the frame for a slab form panel. So the beam form may be built on the shore heads, and the slab form panels can be raised and supported. It's important to see that the kickers aren't placed between the beam sides and the edges of the slab forms. So the kickers prevent the beam sides from being pushed out by the pressure of the concrete and allow easy removal of beam sides when the concrete has cured sufficiently. So take a look at the pictures. You can see the typical flat slab formwork as well as the drop panel form. So also you can see the illustration of the shoring in multi-story construction that can take the form of trusses with adjustable bases. And please note the metal shores under the freshly stripped floor slab. You can see that, and you can see how that is constructed. That's actually very interesting to see. So let's take a look what else we can see here. So there are metal pans in nail down system. Also there's bent leg metal pan, how that works and where that is placed. So and you can see the metal pans in adjustable system as well. So when when the bent leg pens are used, they can be used in two ways. In the nail down system, the pens are placed and nailed to the series of soffit boards supported on stringers and shores, and the depth of the ribs is determined by that of the pens. When the system is used, the procedure is the following. Um, First, erect and support soffit boards. Nail the end caps to the soffit boards. Place the first pan, usually a tapered one, over the end cap. Place the next pan over the first and lap at least 2 inches. Continue setting pans with at least 2-inch laps until they meet at the center. So the other system of using bent leg pans is known as the adjustable system. And you can see there are illustrations showing that. So the procedure for setting up pans this way is as follows. You set up in level stringers, then nail ledger strips to the joists, set joists on the stringers, cut spreaders to length and separators 2¼ inch shorter with ends cut to the slope of the pans. Set the spreaders on the ledger strips. Place end caps on spreaders of each end of bay. Place metal pans on spreaders, then cut soffit pieces from 3/4 inch material wide enough to fit between pans and rest on the top of the joists. So again, there are illustrations here. You can see dome pans for waffle slab. That's quite interesting, and those are those create really beautiful effect from underneath. You can also see the ribbed slab reinforcing, how that works, and you can see the pan forms for a beam and joist two-way ribbed slab. So also there is a diagram showing adjustable wood post, and you can see the metal screw type shore. So when we talk about integrated distribution floor system, uh, a floor and roof system that has been developed by the Portland Cement Association and is specially designed for use in low-rise apartments, light commercial and industrial buildings, and residences. The integrated distribution or ID floor system includes 3 basic components: steel truss tees, forms to be left in place, and cast in place concrete. So it incorporates heating, plumbing, and electrical utilities in the system. The trustees do double duty as supports for the ID forms and as the only reinforcement normally required for a simple span system. So also we can take a look at the ID forms here and steel truss T, how that works. And also there is the illustration showing scaffold supported shoring for ID system. Also, you can see the shims for truss T's supported on non-load bearing partition, how that is constructed, and you can see the section through ID floor. So also there is a detail showing forming for slab and fireproofing. And we're moving to the concrete floors with steel frame. So concrete floors supported by a steel frame are often simple flat slabs. In some cases, concrete fireproofing for the beam may be incorporated with a slab, in which case the structure becomes a beam and slab floor. Although the form is supported from below, the steel frame itself is frequently utilized to support the forms. Reinforcing steel using straight bars for positive and negative bending is placed, and you can see there is an illustration of that. Also, hangers are available in a number of styles and lengths. Long loop hangers allow the top flange and the upper portion of the beam webs to be encased by the slab. Coil hangers make it possible to keep the sheathing tight under the top flanges so that the entire slab is above the beams. So, and you can see there are graphics showing that. So composite floor slabs, they combine the tensile strength of structural steel with the compressive strength of concrete to produce a monolithic section that is more efficient from a load supporting point of view than using the materials individually. So composite slabs are designed in two ways. So the first approach is the structural steel is designed to support the weight of the concrete and the construction loads without any support from temporary shoring. And if corrugated or cellular steel decking is used, it must be securely fastened to the steel frame because it becomes an integral part of the floor system. So you can see there is cellular steel decking, and you can see the corrugated sheet steel decking as well as the spot welding steel deck. So just so that you are familiar with the process. And there's the second approach. So the structural steel sections require temporary support until the concrete has cured sufficiently to provide the necessary bond between the concrete and the steel to produce a true monolithic section. Sections such as this can be developed by bonding the concrete slab to the steel beams with shear stud connectors, by encasing the steel beam completely with concrete, or by using a steel deck anchored to the beams with stud anchors covered with concrete. Again, there is a section showing that. So let's move to the last subsection, that's the industrial floor finishes. So the structural floor described generally requires some type of floor finish. So it may be wood, concrete, tile, cast coating such as epoxy, resilient tile, access flooring, or terrazzo. So let's take a look at those individual ones. Wood floors. It's for the most part used made from both hardwood and softwood in thicknesses from 2 to 4 inches, and that's the nominal size. And widths of strips vary from 1.5 to 12 inches. So please take a look at the pictures here. You can see the details. You can see heavy wood flooring over concrete base, as well as the heavy wood flooring over laminated deck. Concrete floor finishes. It's widely used, and it may consist of a single finished slab or a base and a topping slab. Take a look at the pictures here. You can see how that is done. So a durable surface may be produced on the concrete floor slab by introducing metallic aggregate into the topping. And that is made up of iron particles and have been size graded to within the range of number 4 and number 100 mesh sieves, specially processed for ductility and mixed with a cement dispersing agent, calcium lignosulfate. Tile. Tile flooring is the layer of ceramic tile, cut stone tile, or synthetic stone tile laid over a concrete base slab. So you can see the angles. That's for the reinforcing of expansion joints. And there are also cast coatings such as epoxy or urethane. Epoxy resin is a synthetic that is often used as a bonding agent or repair material in various construction applications. It may also be used as a basic ingredient for floor topping, and it's made of two components, liquid resin and a curing agent. So they're mixed in prescribed proportion and then applied on the top as the top coat. So resilient tile, that includes a number of products such as asphalt, linoleum, cork, vinyl, and rubber. And there are different colors, variations, and thicknesses of those floors. Access flooring. So with the development of sophisticated communication systems, building owners have found that tenants require additional flexibility in the placing of electrical outlets and telecom wiring throughout their office space. So in order to deal with that, and especially in the larger office buildings, the concept of access flooring was developed. So that's like sectional flooring that is placed on top of existing floors with sufficient space for the running of wires and conduits between the two. Usually the height between the two floor varies depending on the needs, and they can range between 6 and 12 inches. Terrazzo floors, that's a composition material cast in place or precast, like if it's in the tile form, and that's used for floor topping and wall treatments. It consists of marble chips with the binder of or matrix, which may be cementitious, non-cementitious, or a combination of both. The terrazzo is cast, cured, and then ground and polished or otherwise finished. Rustic terrazzo is a variation in which quartz, onyx, or granite chips may be substituted for the marble chips, and in place of grinding and polishing, the surface is washed with water or otherwise treated to expose the stone chips. There are a number of types of terrazzo installations, including sand cushion, bonded, monolithic, structural, in which Portland cement paste is used as the binder for the top coat. So plastic resins such as epoxy or polyester or a combination of these with Portland cement may be used as the binder. And please take a look at the pictures, how that is applied. So for the terrazzo installation, it depends on the company and the type of flooring, but a monolithic terrazzo is placed at the same time as the base slab and bonded directly to it. And as a result, any structural movement occurring in the slab is likely to cause damage to the finished floor. So to minimize any such damage, the following steps should be taken when placing the slab. So for on-grade slabs, the fill should be thoroughly compacted. Then a power screed should be used to bring some cement paste to the surface to seal off surface pores. Then all plumbing and electrical conduits should be placed neatly and rise at right angles through the slab. Also, when the slab has set enough to walk on, it should be broomed to roughen it to ensure a good bond. And in large areas, the concrete should be placed in alternating slabs to extend more control over expansion and contraction. So the installation of sand cushion terrazzo is a typical operation as well. And there are steps that associated with that. So for and also there are so many manuals and they're so different, and you can refer for complete information and installation details for all types of terrazzo. You can refer to the terrazzo technical data, and that is published by the National Terrazzo and Mosaic Association. So that was it for chapter 12. Thank you so much for watching. I will see you in chapter 13.